All right, let's try this again. Sorry about that. You don't know what you missed. Okay, so this is kind of a breakdown of your final exam. I looked at it. I wrote down the concepts. First thing you got to know is the binomial theorem. So when you're asked to expand something like that, right there, a binomial to the nth power, you can use Pascal's triangle to figure out the coefficients, these numbers C that go in front, and then you see the pattern of the x's. You begin with 1x to whatever n is, plus wherever the first coefficient is, x to the n minus 1, and then b to the first. And they keep doing that. Next one would be x to the n minus 2, b squared. They keep decreasing, and x keeps decreasing, and b keeps increasing until it's b to the nth. And this is Pascal's triangle, right? You get the bottom number by adding the top two. So 1 plus 2 is 3. So it's 2 plus 1 is 3, and so forth. 1 plus 4 is 5. 6 plus 4 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And you can add another one if you wish. Here is x minus 3 to the 5th. Notice it begins with x to the 5th. Then the first coefficient is 5. X to the 4th, negative 3 to the 1. Notice the 4 and the 1 add up to 5. Then it's a 10. X to the 3rd, negative 3 squared. Then it's another 10. X squared, negative 3 cubed. Then it's a 5x, negative 3 to the 4th. And then it's just a 1, negative 3 to the 5th. All right. Relating graphs to volumetric change. So if you're pouring water or something into a container, the depth of the water changes with the shape of the container. So if you begin with kind of a smaller at the bottom, it'll be going up faster. And then as it expands out and gets wider, that means the cross-sectional area gets larger. And since volume is cross-sectional area times the depth, or delta x, delta h, the height will necessarily slow down increasing until it starts to decrease again, and then it goes up faster. So be aware of how to interpret that. All right, the second thing is these rational expressions like this, being able to break up a non-factored rational expression by factoring. And then you can look for things like the horizontal asymptote, which is the limit as x goes to infinity of this. And that just means you take the ratio of the highest powers. You can look for holes or vertical asymptotes, which are when the bottom goes to 0, as long as there's no common term on top, then those are vertical asymptotes. This has no holes, but it does have 2 vertical asymptotes. If there was an x minus 3, then there would be a hole at x equals 3, and then that would not be a vertical asymptote. Understand what it means to be a polynomial function, f of x divided by x minus a, and understand if the remainder is 0, what that means, it's a factor. Or if the remainder is not 0, what that means. Okay, which means it's the value of the function at x equals a. Now, if it's a factor, the resulting polynomial you get from synthetic division of those numbers are just the coefficients in front of the polynomial with the reduced power of 1 by 1. So if this was an x to the 5th, and you did this, then the resulting polynomial you'll get will be x minus whatever a is, x minus a, times an x to the 4th polynomial. All right, you have to be able to now look at a function like this and decide when is the function increasing or decreasing. It should be easy. When the function's going up, it's increasing. So it's increasing from 0 to a and from what I called C2 to D. It's decreasing from B to C to C1 because the graph is going down, and constant between A and B and C1 and C2. All right? If negative 2, 4 is on g of x, find the point on, that should be g. So let's kill that h and make that g. Make that g. Okay. So quite literally, it's 4 times g of x. Put g of x is 4, so it'll be 4 times 4 minus 1 is 15. So if negative 2, 4 is on g of x, then negative 2, 15 is on y. Okay. From a graph, choose the polynomial function. So given a graph like this, you should look for a function that has x plus 5 as a factor. Notice it just goes through, so it's a multiplicity of 1. And x plus 1, but it bounces, so it's a multiplicity of 2. And then, and x minus 4 with a multiplicity of 3, because it does that funky little jig at the 0. All right? And we knew there was a negative, because if you look at this, this is a degree 1. That's 2. So 1 plus 2 is 3, plus 3 is 6. So it's an even degree. And you notice it's going down here and going down there. So you know there needs to be a negative sign in front because it goes down to the right. And since it's an even degree polynomial, it does the same thing to the left. All right. One of the questions will be given, I think you have a couple of these. I think you have a couple of these too. All right. So another one that you might have a couple of is given a factored polynomial. Can you decide when is f of x negative, when is f of x positive? Okay. And you just do a sign chart. All right. You sit down all the zeros. You got a 0 at x equals 0, 0 at x equals 3, and a 0 at x equals 4. And then you check the sign of the polynomial to the left of 0, between 0 and 3, between 3 and 4, and then between 4 to the right of 4. And you see you get these signs. So whenever you get negative, that means f is less than 0. So it's between 0 and 3 and 4 and infinity. Whenever you get a plus, that means f is greater than 0. So that's from negative infinity to 0 and from 3 to 4. And if you want to know when is f of x, no, that's it on this actually, sorry. Okay, define the degree of a polynomial from a data table. Do differences, i.e. first difference, second difference, third difference, fourth. Keep going until you end up with a constant difference. Okay, I'm going to pause here and start again because it's already 8.5 minutes long. All right, so stay tuned for part 2.